Hello. Today we will solve some problems about atomic mass, Avogadro's number, molar mass, molecular mass, percent composition of compounds, empirical formula determination, and reaction yield, and lastly limiting reagents. So the first question is that which of the following has greater mass? 2 atoms of lead or 5.1 times 10 to minus 3 mole of helium. So we should definitely know molar mass of lead. So this is the molar mass of lead. And so we should also know molar mass of helium, and it is 4.00003 gram per mole. Okay, and which one is greater mass? So we know the Avogadro's number, 6 times 10 to 23 1 over mole. So to calculate the molar mass of 2 lead atoms, it is pretty easy, right? We know the molar mass of the lead, and we know the Avogadro number, and I want to get rid of the mole here basically, so that I should divide this number to Avogadro's number, 1 over mole. So what happens? The mole comes here, since it is 1 over mole. So mole comes here, and we have 2 lead atoms, right? And if you make the calculation, it becomes 6 times 8 times 10 to minus 22 gram. This is the mass of the leads. Similar calculation should be done for the helium. So there are 5.1 times 10 to minus 23 mole of helium. So we know the mass of the molar mass of the helium, since it is gram per mole. If we multiply it, moles will cancel, and we will know the mass of the helium. In this case, we just multiply with molar mass of the helium. So 4.003, and in this case the answer for the mass of the helium should be 2.041 times 10 to minus 22 gram. In this case, mass of lead is higher than mass of helium, so the answer should be helium. Oh, sorry, the answer should be lead. Sorry for the confusion. So in the second question, The atomic masses of chlor is 35. So this is 55.53%. And the other isotope is 3717, and this is 24.47%. The question asks the average atomic mass of chlorine. So what is the average molar mass of chlorine? So we have two isotopes, but we have to make the percent to a ratio. So as a basic knowledge, what is 10%? 10% means that 10 over 100. And simply 75.53% means that 75.53 over 100. So it is 0.07553. This is the ratio of chlor 35. And the other ratio is 24.47%. So it is 0.02447. Oh, sorry, I made a mistake. So sorry for the confusion. I made a mistake in division, so I should put only 0.7553 and 0.2447. So if you want to check the percent, total should be 100, right? In this case, if you add them up, it should be 1, and the answer is 1. So we are in the correct way. And I can make them smaller to gain some space. And okay, so 0.7553 is 34.968 gram per mole. And the other part, 0.2447 times 36.956 is the other isotope molar mass. So these are the isotope masses. This is chlor 37 and this is chlor 35. So if you make the math, the average mass is 35.45 gram per mole or AMU. But we can just use one unit, so I want to use gram per mole. And this is our answer. This is average mass of chlor. We should know the molar mass of copper, which is 36.5 gram per mole, and we have to convert gram to mole, right? So what should we do? We should basically divide the molar mass of copper. Grams will cancel each other since grams are in the same position, but moles is 1 over mole, so moles comes here. And we know the Avogadro's number, 6 times 10 to the 23 1 over mole, and moles will cancel, so we know the number, and this is equal to 2 times 96 times 10 to the 23 2 atoms. So in the fourth question, for many years chloroform was used as an inhalation anesthetic in spite of the fact that it is also known as a toxic substance that may cause severe liver, kidney and heart damage. Calculate the percent composition by mass of this compound. So we have to know the total mass of the chloroform. So in this case, we can look at the molar mass of carbon, molar mass of hydrogen, and molar mass of chlor. The issue is that there are 3 chlor, and this will be molar mass of our compound. If we make the calculation, we have 1 carbon, and 1 carbon molar mass is 12.011 gram per mole, and hydrogen is, there is only 1 hydrogen, and the molar mass of the hydrogen is 1.00784 gram per mole. And we have 3 chlor atoms, and molar mass of is 35.453 gram per mole. So total mass is molar mass 119.37784 gram per mole. I can make it smaller to gain space, and then I want to calculate percent ratio of chlor, hydrogen and carbon. So how can we do that? It is very easy. Firstly, we know the total mass of chlor in all the molecule, so it is 3 times 35.453 gram per mole. By the way, this is 3. And total mass, we have calculated it. And this value, we want to convert it to 100%. So I just multiplied with 100%. And it will make it 0.1%. Same way, I can calculate the percent hydrogen, and it will be very small since hydrogen mass is too small comparing with the whole molecule. Again, I didn't say here, but the units will cancel each other, and here units again will cancel each other, right? We multiplied it with the 100%, and the calculation result will be 0.844%. To calculate carbon, we can make the same thing, or we will add these two numbers and we will subtract from 100. If your calculations, these two are correct, then you will find the percent mass of carbon, since there is no other element. But I don't want to use that, and I will explain why. So there is only one carbon, right, and one hydrogen in the molecule. So carbon molar mass is 12.011 gram per mole, and total mass of the molecule 119.3778 times 100%, and the results become 10.1%. So why I didn't subtract the mass of these two to calculate the percent of carbon? The reason is that I want to check my calculations. The easiest way is summing up my calculated numbers. If I calculate these numbers correctly, then the result should be 100. So 89.1 plus 0.844 plus 10.1, so it is 100. As you see, my calculation is correct enough. In the fifth question, tin fluoride is often added to toothpaste as an ingredient to prevent tooth decay. What is the mass of fluor in grams in 24.6 gram of the compound? Why should we do that? We have to know the mole of this amount of compound, so we should convert it to the mole of tin fluoride. If you know the mole of tin fluoride, then we will know the mole of fluoride part. And molar mass of F is 18.998 gram per mole, and molar mass of tin fluoride is 156.71 gram per mole. We can make them smaller to gain space. So I want to know the mole of tin fluoride. By the way, N represents the mole. And if I want to represent something, I write the name here, but it is not very important. So molar mole of the tin fluoride, not chloride, is, so we have 24.6 gram of tin fluoride, and we know the molar mass of the compound. Gram per mole, but we can write the mole here. And if we make the calculation, you will see that grams will cancel and the mole becomes 0.156 mole. What should be important here? There are 2 F atoms in tin fluoride. So mole number of F is 2 times 0.156, and it is equal to 0.314 mole. We know the molar mass of F, which is 18.998. So lastly, we can calculate the mass of the floor, since we know the mole of the floor. Mole will be cancelled and calculated number will be 5.9646. In the sixth question, monosodium glutamate MSG, a food flavor enhancer, has been blamed for Chinese restaurant syndrome, the symptoms of which are headaches or chest pains. And MSG has the following composition by mass: 35.51% carbon, and maybe we should write them or sign them. Percent carbon, 4.77% hydrogen, 37.85% oxygen, 8.29% nitrogen, 13.60% sodium. Okay, we write them. What is the question? What is its molecular formula if its formula mass is about 169 gram? So molar mass of the compound is this, and we know how to find percent ratio of an element. Firstly, we have to know the molar mass of atoms. So carbon is 12, hydrogen is about 1, oxygen is 16, nitrogen is 14, and sodium is 11. We can find them in the periodic table, or like me, you could memorize. So 12 carbon, I don't know how many carbon are there. So I can write an X here. and molar mass of that molecule is 169 times 100 should be equal to 35.51. So if you make the calculation, this X will be very close number to 5. So there are 5 carbon. If you make the calculation for hydrogen, similar calculation, 4.77 is a percent ratio. So 4.77 should be equal to 100, comes from the 100%, but the percents will cancel, so I will not write the percent here, not to confuse you, and I don't have so much space. So molar mass of the molecule is this. Molar mass of hydrogen is 1 for hydrogen, and again I will put X here. If you make the calculation, this value becomes close to 8. So hydrogen is, there are 8 hydrogens. I will make this similar calculation for oxygen. And molar mass of oxygen is 16. I don't know how many of them. I will write X. Molar mass of the molecule 0.69 times 100 should equal to this number. So if you make the calculation, this X becomes 4. And oxygen 4. There are 4 oxygen. So I will make them smaller. And we can continue with nitrogen. So this X will become about 2. So there are probably 2 nitrogens. Oh, not 2. It should be, it is 0. So I can calculate. Yes, it is very close to 1. 1.00072 and goes on. So it is just 1. There are 1 nitrogen in the molecule. And lastly, sodium 11. This is the molar mass of sodium. There should be this amount of, oh, by the way, I forgot to write 100 here. 100, and it is equal to 13.6. So this number becomes very close to 2. And this is the expected result for our question. This is the molecular formula of MSG. So balance the following equations. Firstly, I will just balance the first one. Copper reacts with nitric acid and creates nitric copper nitrate NO and water. If you realize, this is a redox reaction. So copper becomes copper 2 plus and nitrogen is reduced. So this is the oxidation and this is the reaction. And I want to write them separate to balance them. Copper 0 became copper nitrate and I want to balance this reaction. How can I do that? Firstly, I should add at least nitric acid. If I add nitric acid, then I should add hydrogen ions here. But I don't know how many. And this copper 0 become copper 2 plus, so it should take at least 2 electrons. So this part should give 2 electrons. If it takes 2 electrons, then I should have at least 2 nitric acid molecules. But hydrogen becomes 2 here, and I want to also balance the nitrite here. Right? There should be 2 actually for that. And if I put 2 nitric acid here, then I should put 2 proton here. So this is the proton, right? This is proton. But it is not so important right now, but I just want to give the idea. So this is balanced. So if you balance the oxidation reaction. So this was the oxidation reaction. Since copper 0 becomes copper 2 plus. And there is also a reduction. Nitric acid has reduced. And became NO. And water. But I don't know how much. And I can add 3 electrons here. And I added 3 electrons, and I have to add actually 3 protons. just a simple trick. To equate hydrogen and oxygen, I can write 2 here. So this is our reduction reaction. So I could balance these two reactions. But electrons and hydrogens should cancel each other. To cancel them, I will multiply this reaction with 3 and I will multiply the bottom with 2. If we add them up, these two reactions, the total reaction will be this thing: 3 copper, 0, 6 nitric acid, 2 HONOH comes from here. So I can simply write eight the other side becomes then we should check. The nitrogen is the most tricky one, I think. So we have 6 nitrogen here and 2 nitrogen here. So we have 8 nitrogen. We have also 8 nitrogen here. So nitrogen checked. Copper checked. 3 copper here. 3 copper here. Good. And lastly, oxygen. We have 24 oxygen. We have 6 times 3, 16 oxygen. Two oxygen here, 20, and 4 oxygen here, 24 oxygen. Okay, good. So this is the balanced equation since hydrogens also equal to each other. There are 8 hydrogens here and there is 8 hydrogens here. So this is the balanced equations. You can make other reactions, these two, to practice. And the other question: consider the combustion of carbon monoxide in oxygen gas, starting with 3.6 moles of carbon monoxide. Calculate the number of moles of carbon dioxide produced if there is enough oxygen gas to react with all of the carbon monoxides. So it is an easy question, I think. Carbon monoxide, oxygen, and this is excess. Okay, we don't have to worry about oxygen. So we have 3.6 mole of carbon monoxide and there is a 1-to-1 ratio. So if the reaction yield is 100%, then we should produce 3.6 moles of CO2. Since the ratios is same, 1 to 1. So the answer is 3.6. And question 10. Consider the reaction manganese oxide reacts with HCl and produces this molecule, magnesium chloride, Cl2 and water, and these are the mole of the manganese oxide, HCl, and the question is which reagents will be used up first, how many grams of Cl2 will be produced. So I want to write the reaction on a clean surface. And we have to know the molar mass of HCl and molar mass of Cl2. And this is 35.45 gram per mole, and this is 36.46 gram per mole. So we have 0.86 mole of manganese oxide, but we don't know how much HCl in terms of moles. So I want to convert its mass to mole. And how can I do that? Simple. This is the mass of the HCl, and molar mass is 36.46 grams per mole. And I can write the mole here. It can go up, and grams will cancel each other. So if you make the calculation, it will become 1.32 mole. Which one depletes first? So there is a 1:4 ratio. If it goes minus X, then HCl should deplete -4. And I am sure that HCl deplete more than it, since if 0.86 mole depletes from the manganese oxide, then 4 times 0.86 mole should be depleted from the HCl, and it is not possible. Therefore, our limiting reagent is HCl. But how much HCl will be consumed? HCl is the limiting reagent, and we have to calculate it, how much goes from the HCl. It will deplete first. Therefore, 1.32 gram should equal to 4x, since it will deplete approximately 4x, and x becomes 0.33 mole. If you deplete minus 0.33 mole of manganese oxide, we produce 0.33 mole of Cl2 gas, and we know the molar mass of the Cl2, which is this. And if we want to convert it to the gram, we will just multiply it with its molar mass. So this is mole. Maybe I should write it again. So it will go, moles will cancel each other, and the mass of the Cl2 gas will be about 12 gram. And this is the last question. When 0.273 gram of magnesium is heated strongly in nitrogen, so there is a reaction something like this. A chemical reaction occurs. The product of the reaction weight is about 0.378 grams, so we produce something, but we don't know its formula. And question says that calculate the empirical formula. So we have 0.273 gram of magnesium. We don't know how much nitrogen, and we don't know the ratio between these two numbers, but we know that the mass of the product is this. And if we subtract 0.378 minus 0.273, it is 0.105 grams. Since total mass must be conserved. So nitrogen mass is 0.105 gram. I want to convert these grams to moles. We have to convert all the numbers, and if you want to convert it, we have to know the molar mass of magnesium, molar mass of N2, and magnesium molar mass is 24.345, and nitrogen molar mass is 28.014. So we have to convert it, and these are grams per mole, of course, grams per mole. 1/24/305 grams times mole. Grams will cancel each other, and the number will become 0.0112. So I want to clean down. 0.112. This was 0.105 gram. This is mole, and I should convert it to the mole, and I can do it in the same way. I will just divide it to molar mass of the nitrogen, which was about 28.014 gram per mole. I will divide it. And the number will become 0.003747 mole. So this is this nitrogen mole number is 0.00374 mole. But we have to consider the number of atoms or moles. So we have to multiply this number by 2, since there are 2 nitrogens in N2. In this case, number of nitrogen atoms or mole of the nitrogen atoms should be 2 times 0.00374, which is 0.00794 mole. So this goes here, and we calculate magnesium here. I want to make them smaller, and actually question nearly finished. Since magnesium 0.112 and nitrogen 0.007494. So I want to write an empirical formula. So which number is the smallest? This number is smaller than this one, and I have to divide them, the small one. If you make the calculation, it will become magnesium 1.5, nitrogen 1, and so there is a 3:2 ratio, or we can multiply both sides with the smallest integer, and the empirical formula becomes magnesium 3, again I made a mistake, nitrogen 2. This is the answer of this question.